All right, so we're going to be starting chapter 4 today. We're going to do two sections at once because the first section is, well, let's face it, middle school material. Okay?
Listen up, Edis, this is gonna be hard for you. It's gonna be hard for you, Leslie. It's impossible.
Wow.
Didn't you get a...
Everybody's so mean over here. All right, so what is a triangle? A triangle is a polygon with three sides. Triangles are classified by their angle measures and by their side lengths, so you can classify them two different ways. So acute has to have three acute angles.
Yay!
Ooh. A right triangle has one right angle.
Yay!
Now, how many acute angles does it have? Two. So one of the true-false questions that sometimes people will ask is they'll say, if a triangle has an acute angle, then it's an acute triangle.
No.
That's false. Every triangle has an acute angle in it. Fact is, every triangle has at least two acute angles in it, at least in our form of geometry. In spherical geometry, you can make a triangle that has three right angles in it, but that's another story.
What?
I'll show you if we have time after the lesson.
Yay!
All right, an obtuse triangle has one obtuse angle and, again, two acute angles.
Yay!
Okay, that's gotten old now. Thank you. And then an equiangular triangle, that's a new term for you, but it's pretty easy to figure out. Please notice that it's not equal angular. There's only one L in this. It's E-Q-U-I, angular. But the name tells you exactly what it is, right? The root word is angle, and the prefix E-Q-U-I means they're equal. It has equal angles. All the angles are congruent, and they have to all be acute. Okay, we'll talk more about equiangular triangles in a bit. And then by the sides, scalene triangle, none of the sides are congruent to each other. They're all different. An isosceles triangle has, notice I've underlined this, at least two congruent sides. By the way that your book defines it, if it has three congruent sides, it is equilateral and it is also isosceles. So equilateral, again, notice EQUI, lateral mean sides, just like you guys are taking world geography, right? Mm-hmm. So on a globe, the equator and the Tropic of Cancer and the Tropic of Capricorn and the Arctic Circle and all those are what kind of lines? Latitude. Same root word. Lateral, latitude, all those have the same root word, so it means sides, because they go side to side. Okay? And EQI, again, means the same.
Equip.
Yes. So these are also isosceles. So in this picture, let's classify each triangle by its side lengths. So if we're looking at triangle KYR, what kind of a triangle is that? Yes. What about triangle YRA? It certainly looks scalene. We have no information that it's anything else. And what about the big triangle, triangle KYA?
Scalene.
It looks scalene to me as well. Don't count on there being a lot of test questions like this. Like I said, this is sort of junior high material. Page 2. Now here let's classify each triangle by its angle measures. So if we're talking about triangle JAM, well, they've given you 2 of them. They didn't give you the third one. We'll talk more about that in a second. But that third one looks pretty small, right?
Yes. So acute.
Acute, because all 3 angles are acute. What about triangle AME?
Acute.
Well, what's the measure of this angle right here? 100, because those 2 are a linear pair.
Right. So it's obtuse.
So it's got to be obtuse. And then let's talk about angle JAE. And you're like, oh. Well, in order to do that, you really need to know something that you've known, again, since junior high. What do the angles in a triangle add up to?
180.
180. So 100 plus 20 is 120. Subtracted from 180 leaves it, this angle is 60. Up here, if we look at triangle JAM, we said this one looked small, and it indeed is. 80 plus 60 is 140. From 180 is 40 degrees.
So it's an equilateral.
We're classifying them by their angle measures.
Equiangular.
Yeah, equiangular. Now, you've known that the angles in a triangle add up to 180, again, since you learned that at some point in middle school, right? What I find is almost no one knows why. Their teacher told them, you all nodded because you're smart people and you trust your teacher. You all nodded and went, okay, yeah, that makes sense.
Can I guess?
Can you guess why?
Yeah.
Yeah, absolutely.
Because if you line up all the angles together, it'll be supplementary line.
So what you're talking about, I think, if I'm following you, is that if I was to take a triangle, let's say it looks like this, and I was to rip off this corner and this corner and this corner and line them all up,
Yeah.
it would look like this. I would have these 3 angles, and it would make 180.
Yeah.
Yes.
Yes.
Now, that's not really a proof, but we could do that. If you cut out a triangle and you ripped off all 3 angles, stuck them together, it would make this. Another way that you can do that is if you were to take a triangle like this and fold it. So if you fold this edge down, you don't need to draw this, it would look like this. And then fold this edge over, it would fold right to here. This angle would exactly fit right there. And fold here, this angle would fit exactly here, and you would have those same 3 angles, kind of like you did here without having to destroy your triangle, right? Again, is it convincing? Absolutely. Is it a proof? Not by a long shot. Let me show you just real quickly how we could prove that all that's true. Again, just watch. You don't need to do anything in particular. So let's call these angles 1, 2, and 3. My job is to prove that angles 1, 2, and 3 are congruent. Or excuse me, add up to 180. Okay? One of the things that this proof rests on is if I have a point up here and a line down here, how many different lines can I draw through this point that would be parallel to this line down here?
One.
There's just one. It's unique. right? There's only one. I'm going to call this angle 4 and this angle 5. What do angles 4, 2, and 5 add up to?
180.
180, because that's a straight angle, right? So I'm doing the proof without writing all the reasons and stuff. Nelson, next time I see that open while we're doing notes, I'm just going to take it away from you, okay? So those add up to 180. And if these are really parallel to each other, what else do I know?
3 and 5 are congruent.
Yep. And?
And
1 and 4 are congruent. I should mark them differently, shouldn't I? So replacing or substituting, I have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180. Now, the reason that your middle school math teacher who taught you that the angles add up to 180 didn't do this is because you weren't ready for it yet. Right? They weren't being mean. They weren't withholding something good from you. This is actually a spiritual lesson as well. There are times when you really want something and it's not time for you to have that thing yet. And so God goes, yeah, you're not going to have that yet. Whatever that is.
like a phone.
Pardon?
Like a phone.
Like a phone, I suppose. I was thinking, more something a little bigger, not necessarily like I've wanted to be a grandfather for a long time. Right? Well, I'm actually going to be a grandfather twice over this spring. My daughter is pregnant and my daughter-in-law is pregnant.
Oh, wow.
So one due at the end of March, the other one due middle of April.
And these will be their first children?
Yes.
Oh, wow.
So those will be my first grandchildren, and I'll have 2 in less than a month. So looking forward to that. Anyway, so this is the triangle sum theorem. Again, you have known this for a long time. The sum of the angle measures of a triangle is 180 degrees. Here, the measure of R plus the measure of S plus the measure of angle T is 180. Now, we can use that to find angle measures. Again, this is maybe slightly more advanced than junior high, but not much. So if I'm looking for angle RST, this angle right here, I can use triangle RST. The angles have to add up to 180. So far, I've got 62 plus 40 is 102. From 180 is 78. Now I want to find the measure of angle SQR, or just angle Q. There are 2 entirely different ways to approach this. I'm happy to take any suggestions that you would have. Christina?
Use a big angle, QST.
Okay, use the big triangle, QST. How much is this whole angle up here?
90.
It's 90. 12 plus 78 is 90. So I could do 90 plus 40 is 130. From 180 leaves exactly 50. There is a different way to approach this rather than using the big triangle. Yes?
62 and so SRT and SRQ are a linear pair.
Yep, hang on, let me show everybody what you're talking about. Right here, these two are a linear pair. Go on.
And so then if you find that angle,
That angle.
I mean SRQ, if
Yep.
you find that angle, which is 118 degrees,
We'll find that by subtracting from
62
180.
180.
So this is 118.
And then you add 118 and 12, which is 130, and then subtract that from 180.
And you get 50 that way. Took a little bit longer, but that's absolutely correct. So sometimes looking at the bigger triangle will be the faster option. All right, I want you to notice a couple of things about this particular problem. In the big triangle, the whole angle at S is 90, right? The other two angles in the big triangle, Q and T, what do they add up to? 90. What do we call two angles that add up to 90?
Equal or complementary.
Complementary angles, exactly. That is a corollary to this theorem. The acute angles of a right triangle are complementary. And this shouldn't say angle R and angle T are supplementary. I gotta fix that one of these days. Should be angle S and angle T are complementary. Please make that change. That's helpful because then, don't write this down, but if I know that this angle is 37, do I need to add 37 and 90 and subtract it from 180? No, I can just do 90 minus 37 and find the other angle. Way faster. Okay, it's only one operation instead of two. I told you we'd come back to equiangular triangles. The measure of each angle of an equiangular triangle has got to be 60. If they're all the same size and they add up to 180, dividing 180 by 3 gives us that each of those angles is 60. So if it's equiangular, each of the measures of the angles is going to be 60. Now I want you to notice one other thing. I'm going to go back to this diagram for just a second. See this angle right here that's 118? Everybody add 78 and 40. It's 118. This angle over here outside of the triangle QRT is equal to these other two angles inside the triangle that are not right next to it. These two angles add together to be this one. The reason why is because these three angles, the 78, the 40, and the 62 add up to 180. And then these two angles, the 118 and the 62, also add up to 180. Okay? Now, we have a corollary for that. But first you need to learn about some terms. The angles of a triangle are also called the interior angles of the triangle. An exterior angle is formed by one side of the triangle and the extension of an adjacent side. So here, 1, 2, and 3, interior angles. Most of the time we don't bother calling them interior angles because when you draw a triangle, you instantly have these, right? To get an exterior angle, you've got to extend one of the sides. 4 and 5 here are exterior angles. So in this picture, see how angle 1 and 2 are inside the triangle, but they're not next to angle 5? We call those the remote interior angles. Now, because of televisions, people have the wrong idea about what the word remote means, or frequently do. Is anyone confident of what remote means? Yes, ma'am.
It means like kind of, or close to, or
No? Yes?
far.
It means far away from. If something is remote, it is far away from something else.
Remotely away.
Like a remote island. That was
A remote island, yes.
Oh.
We went to a remote location so that we could be alone.
Because the remote is like far away from the TV, so you don't have to like get up, turn the wheel on the TV.
Yeah, once upon a time, and I'm old enough to remember this, if you wanted to change the channels or heck, adjust the volume, you had to get your butt up off the couch, walk over to it, and turn the dials.
Oh.
Okay?
Whoops.
So, what are angle 4's remote interior angles?
Angle 1 and angle 3.
Yeah, angle 1 and angle 3. It's the two angles inside the triangle that are not right next to it. In other words, the one that's not a linear pair with it. And this gives us what's called the exterior angle theorem. I use this one a ton, and it makes problems go a lot faster if you will use it, even when you don't have to. And then sometimes you have to. It says that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So back up here, the measure of angle 5 is equal to the measure of angle 1 plus the measure of angle 2. The measure of angle 4 is going to be equal to the measure of angle 1 plus the measure of angle 3. So let's add that one. The measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 3. Again, it makes problems where you're having to find a lot of angles. Using this theorem, a lot of times it makes your work faster and you're less likely to make a mistake because you're doing fewer computations. This example, though, you have to use the exterior angle theorem. So notice I have the triangle and I've extended one side. The angle formed by a side of the triangle and an extension of one side. This is your exterior angle because it's outside of the triangle. And these are the two remote interior angles. It's the two angles inside the triangle that aren't right next to it. They're away from it. So the exterior angle, 5x minus 60, is equal to the sum of the two remote interior angles. So it's 5x minus 60 is equal to 2x plus 18. So 3x, add the 60, is equal to 78. X is 26.
And then you just sub it into 6.
Then we substitute in to find the measure of angle B. It'll be 2 times 26 plus 3. It's 52 plus 3 is 55 degrees. Okay, any questions about that? All right, your assignment is in the book. And I'm going to pass back your tests also.